When designing an experiment, there are three principles of design. Those are control, randomization, and replication. You want to try to have all three in a good experiment. What is control? Well, control in an experiment helps to reduce the effects of extraneous variables, or we call those lurking variables. We control sources of variation other than the factors we are testing by making conditions as similar as possible for all treatment groups. If your groups are controlled as much as possible, then we can truly see what the effect of the condition you're testing does to each group. And you can compare the response to a treatment by sometimes having other treatments, no treatments, and when you have no treatments, you're often comparing it to something called a control group, or you might have a combination of these two. Randomization refers to the practice of using chance methods. You could use your calculator generator, your random number table, flipping a coin, choosing an SRS based on numbers from the back of the book to help reduce bias. You really are choosing who goes in which group randomly rather than you picking them and putting them in specific groups. The goal of randomization is to create treatment groups that are similar. Again, then we can really see what the effects of the one condition we're looking for. Right? Without randomization, we cannot use the methods of statistics to draw conclusions. Right? If you don't randomly choose your subjects, you're throwing in bias, and the minute we have bias, all our results are null and void. And finally, replication. You want to have replication because it refers to the practice of assigning each treatment to many, many experimental units. You don't want to just have one person in one treatment and a second person in another treatment because you might get odd results just from one person. So the more people you can have in each of your treatment groups, the better it is, the lower the variability will be on what you're measuring. So really, replication means repeat, repeat, repeat. Have many subjects or experimental units in your experimental design. You can explain each experiment with a diagram. Here's the basic form of an experiment. In this experiment, let's say we start out with 30 rats. Then, through random assignment, or your book often uses random allocation, again, it deals with the fact of randomization. You are going to randomly pick your rats into two different groups. 15 go in group 1 and 15 go in group 2. Then, with the arrows going across, you can show your different treatments. In this case, there are two treatments. The new diet that the rats are getting, and your second treatment really is your control group, and that's your standard diet. And then you want to compare the weight gain between the two groups. Right? So as you're diagramming an experiment, you always want to start with this random allocation or random assignment, split it into how many groups you need, depending on the factors and the levels that you have, explain each treatment, and then ultimately compare in the end. And you can see each of our three principles in this diagram, right? Control. You have more than one group to help reduce any lurking variables. Randomization, right at the beginning, you are randomly assigning the rats to each group so that each group is as similar as possible. And repetition. Within each group, we have 15 rats and 15 rats. Now you try an example. Again, think about how many factors or levels or treatment groups you're going to need when you're diagramming your experiment. So in an experiment to see if getting candy after a meal would entice customers to leave a better tip, a waitress randomly decided what to do with 80 dining parties. Some got no candy, some 1 piece, some 2 pieces, and some got 1 piece, and then the waitress suggested they take another. She then recorded the tips that she received. So think about questions A, B, and C. What are the experimental units? how many factors, levels, and treatments are there, and what's the response variable, and you can use all of those to help you diagram this experiment. So go ahead and pause the video and see if you can answer A, B, C, and D. The experimental units are the 80 dining parties. How many factors? There's just one, being the amount of candy they received. How many levels? There's 4 levels. Your treatments are the no candy, 1 candy, 2 candy, or 1 and then offers of more candy. And your response variable is the tip amount that the waitress received after each party. We can use all this information to help diagram this experiment. So here we have our random assignment or random allocation of the 80 parties. Since we know we have 4 treatment groups, we're going to draw 1, 2, 3, 4 arrows and have group 1 with 20, group 2 with 20, group 3, and group 4. And again, remember, they are randomly put into these groups. Each of these groups has one of the treatments, no candy, 1 candy, 2 candies, 1, then the offer of more. And then at the end, you are going to observe and compare the tips that they got. And again, remember our good principles of design for an experiment. Control, randomization, and repetition can be seen in our diagram, right? We're controlling by creating more than one group to test the treatments on. Randomization happens right at the beginning, right? We're randomly putting people into groups to help get rid of bias. And repetition, right? We're not doing it on just one party or 4 parties. Each group has 20 parties to help with the repetition. And that's how you diagram an experiment using the 3 principles of control, randomization, and repetition.